Somewhere in a shipyard on the Baltic coast of Germany, a machine capable of lifting 9 fully loaded Airbus A380 jets in a single motion lay in pieces. Weeks earlier, it had been called the future of offshore engineering. Now it was scrap, twisted steel, and an insurance nightmare. This is the story of Orion, one of the most expensive and advanced heavy-lift vessels ever built, and the single test that nearly ended it before it even began working. Have you ever wondered what happens when a machine engineered to the absolute edge of what steel and physics allow finally meets its limit? In May 2020, the world found out. To understand why this collapse mattered so much, you have to understand what the industry was betting on. By the late 2010s, offshore wind energy had stopped being an experiment and started being an arms race. Countries across Europe were racing to plant enormous turbines out at sea, and each new generation of turbine was bigger than the last. Bigger turbines meant heavier foundations, heavier steel jackets, and heavier monopiles driven deep into the seabed. The vessels built a decade earlier simply could not lift what the new wind farms required. Somebody needed to build a machine that could handle components too heavy and too tall for anything else afloat. This wasn't happening in isolation either. Across the maritime engineering world, a quiet arms race had been building for years. Liebherr had its semi-submersible giant Sleipnir, capable of lifting 10,000 tons with each of its twin cranes. Allseas had Pioneering Spirit, a vessel so large it could lift entire oil platform topsides in one motion without a crane at all. Every major offshore contractor understood the same brutal math. Whoever owned the vessel capable of lifting the heaviest, tallest components would win the contracts nobody else could even bid on. This was not simply about building a bigger crane for the sake of a record. It was about survival in a market where the next generation of wind turbines was already being designed around foundations that no existing ship could handle. That task fell to DEME, a Belgian marine engineering giant with a reputation for solving problems nobody else wanted to touch. In 2018, construction began on a vessel unlike anything before it. It was named Orion, after the Hunter constellation, and everything about its design leaned into that image. A predator built to stalk the hardest lifting jobs in the industry and simply take them. The hull alone stretched 216.5 meters, wider than a football field is long, with an unobstructed deck the size of several city blocks. It was built at the COSCO shipyard in Qidong, China, then sent across the world to Rostock, Germany, for the one component that would define its entire existence, the crane. That crane was called the HLC 295000, and Liebherr, the German-Swiss engineering firm building it, considered it the single most ambitious machine in the company's history. Its boom alone measured 160 meters. The completed structure towered 90 meters into the sky, nearly the height of a 30-story building, mounted on a base pedestal weighing 800 tons by itself. When fully assembled on Orion's deck, the crane could lift objects to a height of up to 180 meters, almost twice as tall as the Statue of Liberty. Its rated capacity was staggering, 5,000 tons in a single lift. To put that in perspective, engineers like to describe it as being able to hoist 9 fully loaded Airbus A380 aircraft at once, or an entire small apartment building, and swing it through the air like a toy. Building something at this scale meant nothing about it could follow ordinary rules. The base column of the crane needed to be only 16.8 meters in diameter, an almost impossibly compact footprint for the forces it would need to resist. Thousands of tons of steel were shaped, forged, and welded into components so large that transporting them required specialized cargo cranes just to move the pieces into position. A secondary crane, the TCC 78000, itself rated at 1,600 tons, had to be built purely to assist in assembling the HLC 295000. It took an entire supporting industrial operation just to construct one crane. There's a detail about heavy lift crane engineering that most people never think about. The bigger a crane gets, the thinner its margin for error becomes. A small construction crane might be built with a safety factor of 5 or 8 times its rated load, meaning it could theoretically survive several times the stress it's designed for. But once a crane moves into the multi-thousand-ton range, that cushion collapses dramatically, sometimes down to barely more than its actual working load. Engineers don't have the luxury of stacking on extra steel for peace of mind, because every extra ton of material is a ton. The crane itself has to lift before it lifts anything else. At this scale, precision replaces margin. There is very little room left for anything to go wrong. By February 2020, the HLC 295000 sat completed on Orion's deck. DEME and Liebherr had already begun celebrating publicly, describing a vessel that would define the next era of offshore construction. Orion's first assignment was already locked in, the Moray East wind farm off the coast of Scotland, a 950-megawatt project requiring the installation of 103 massive steel jacket foundations. The vessel was scheduled for delivery in May 2020. Everything before final handover, however, still had to pass one unforgiving test, the overload trial. An overload test is standard procedure in the heavy lift industry, and it exists for exactly one reason: to prove, under controlled conditions, that a crane can survive forces beyond what it will ever be asked to handle in normal operation. Regulators require it. Insurers require it. No responsible operator would ever put a crane into commercial service without it. For the HLC 295000, this meant lifting a load far beyond its rated capacity, using a heavy barge tethered to the hook as a test weight and gradually increasing the strain until the crane proved it could take the punishment and hold steady. On a Saturday in early May 2020, that test began. The target load for the exercise was 5,500 tons, 10% above the crane's rated 5,000-ton limit, the standard safety margin demanded for certification. Engineers on site monitored every gauge as hydraulic systems groaned under the mounting tension. Cranes of this size are never tested casually. Every lift is choreographed in advance, calculated down to the angle of the boom and the exact sequence of hydraulic adjustments, because there is no room to improvise once thousands of tons are hanging in the air. On this particular Saturday, the yard was quiet except for the deep mechanical groan of the winches taking up strain. The barge lifted slowly from the water. The boom held. The pedestal held. For a moment, it looked like just another successful step in a long certification process. Then, at roughly 2,600 tons of load, less than half of the intended test weight, something failed. Witnesses described what happened next as instantaneous. The main hook, a single forged piece of steel designed to anchor thousands of tons of force, snapped. In an instant, the enormous tension holding the boom in careful balance vanished. Physics did the rest. With the load suddenly gone, the boom's own counterforce had nowhere to go, and the entire structure whipped violently backward, folding over itself like a fishing rod snapping in slow motion before crashing down onto the vessel's deck and superstructure. 12 people were injured in the chaos. Miraculously, no one was killed. The crane, less than 3 months old, was left in ruins. Video of the collapse spread within hours, and for an industry that had just spent years hyping this exact machine as the pinnacle of maritime engineering, the footage was almost surreal. Here was the largest crane Liebherr had ever built, destroyed during the very test meant to prove its strength. Speculation exploded across shipping forums and industry message boards almost immediately. Some pointed to design flaws in the untested HLC series. Others whispered that a machine pushed this far past ordinary engineering limits was simply never going to survive real-world testing. For a few days, nobody outside the investigation team actually knew what had gone wrong, and the uncertainty itself became part of the story, the sense that something this advanced could fail so completely, so suddenly, without warning. Online, the reaction split in two directions almost overnight. Maritime engineers and shipyard workers dissected the leaked footage frame by frame, arguing over exactly which cable had failed first and whether the ballast system had reacted correctly as the vessel rolled. Casual viewers, meanwhile, treated it as pure spectacle, a real-life disaster movie starring the most expensive crane on Earth. Both reactions missed the more sobering truth underneath. This wasn't a freak accident born of bad luck. It was the entire purpose of an overload test being fulfilled in the most dramatic way possible by finding the exact point where an unproven design gave way. The real explanation, once Liebherr's engineers pieced it together, turned out to be less mysterious than the rumors but no less humbling. Preliminary findings pointed to a fault in the crane hook itself, a single component failure that triggered what investigators called a chain reaction throughout the lifting system. The hook, a massive forged unit designed specifically for loads in the multi-thousand-ton range, gave way well before its theoretical limit. Once that single point failed, there was no redundancy built in that could stop the sudden release of stored mechanical energy from tearing through the rest of the structure. It was not corrosion, not a design conspiracy, not sabotage. It was a flaw in one critical forged part. At the exact moment, thousands of tons of force were relying on it. Liebherr's own statement afterward was almost clinical in its restraint, describing the damage as amounting to a high double-digit million-dollar figure and confirming that the accident had no effect on day-to-day operations at the Rostock facility. But for DEME, the company that had ordered this vessel specifically to dominate the emerging offshore wind market, the timing could not have been worse. Orion's crane wasn't just late, it was gone. The vessel that was supposed to be delivered within weeks was now, in the company's own words, still officially under construction, legally owned by the Chinese shipbuilder rather than DEME, sitting in a German shipyard with a mangled crane bolted to its deck. The Moray East project could not simply wait. Jacket foundations don't install themselves, and wind farm construction schedules are governed by brutal weather windows, insurance deadlines, and contractual penalties that accumulate by the day. DEME's spokesperson admitted within days that the company was scrambling to find any replacement vessel it could, either from its own existing fleet or chartered externally, just to keep the Scottish project moving. That replacement turned out to be a jack-up vessel called Sea-Jack's Scylla, brought in to cover work that Orion was supposed to be doing. Meanwhile, the ship that had been marketed as a revolution in offshore engineering sat where it had fallen, its crane a broken skeleton, its purpose completely on hold. This is the part of the story that rarely makes headlines because there's no dramatic footage of it, only paperwork, engineering reports, and months of silence. Repair work on the HLC 295-000 didn't even begin until September 2020, 4 months after the accident, once investigators had finished their analysis and engineers had designed a fix. Liebherr estimated the repair would take through the entirety of 2021 to complete. The repair itself wasn't a simple matter of replacing a broken hook and reattaching the boom. Engineers had to redesign the failed component from the forging up, subject the new part to a battery of stress testing far more rigorous than the original, and then re-qualify the entire lifting system before anyone would trust it with real cargo again. DEME, rather than simply waiting passively, used the downtime to keep investing in the vessel's future capability, later contracting equipment supplier Heisman for a 2,300-ton lifting spreader and specialized damping winches, upgrades meant to make Orion's eventual return even more capable than originally planned. It was a strange kind of faith, pouring more money into a vessel that, for all anyone knew at the time, might never generate a single dollar of revenue. Think about what that actually meant in practice. A vessel that had cost hundreds of millions of dollars to design and build, backed by contracts worth well over $1 billion in offshore wind installation work, sat essentially inert for close to 2 full years. Not sunk, not officially scrapped, but functionally abandoned, stripped of purpose, parked in a yard while the industry it was built to serve moved on without it. Imagine being one of the engineers who had spent years designing this crane, watching it finally reach completion, only to see it torn apart in seconds and then left standing, unused, for 2 years while replacement vessels absorbed the work it should have been doing. Imagine being a DEME executive, explaining to wind farm developers, to insurers, to shareholders, why the flagship vessel of the company's fleet had become a stationary liability instead of a revenue-generating asset. During those 2 years, competitors in the heavy lift industry did not pause to wait for Orion to recover. Rival vessels absorbed contracts, wind farm developers signed with other installation companies, and the entire premise that had justified building the most expensive crane vessel of its generation, that nobody else could do this job, was quietly being disproven by the market itself. This is far from the only time the heavy lift world has watched a record-breaking machine humble itself in public. In 1999, a massive crawler crane, nicknamed Big Blue, collapsed while building a baseball stadium roof in Milwaukee, killing 3 ironworkers after miscalculated wind loads overwhelmed a structure everyone had trusted completely. In 2020, the same year as Orion's accident, another brand-new offshore crane failed during testing at a different European yard entirely, also the result of a hook and rigging failure under load. These machines occupy a strange corner of engineering where success and catastrophe are separated by a margin too small to see with the naked eye, and history keeps proving that no amount of reputation, budget, or ambition makes a crane immune to that math. There's a particular kind of engineering failure that's almost worse than total destruction, and this was it. A sunk ship gets written off, insurance pays out, everyone moves on. But a vessel that's merely broken, expensive to fix, and sitting exactly where it failed becomes a slow, grinding cost with no clean resolution in sight. For nearly 2 years, that's exactly what Orion was. Neither a total loss nor an operating asset, just an enormous, silent, unresolved question mark floating in a German shipyard. Then, in April 2022, almost exactly 2 years after its original scheduled delivery date, Orion finally left the yard. The repaired HLC 295000 had been tested and certified. The vessel sailed to DEME's offshore base near Vlissingen in the Netherlands for its long-delayed naming ceremony, the same ceremony that should have taken place 2 years earlier. Within months, Orion was finally doing the job it had been built for, installing enormous XXL monopile foundations at the Arcadis Ost 1 wind farm in the German Baltic Sea, foundations so large that no earlier generation vessel could have handled them. From there it moved on to decommissioning work in the United Kingdom and eventually crossed the Atlantic entirely, arriving in American waters to install foundations for Vineyard Wind and later the Coastal Virginia Offshore Wind Project, a development tied to contracts worth close to $2 billion on its own. Dominion Energy, the utility behind that American project, would later describe Orion as an essential piece of equipment, one of the few vessels in the world capable of installing the scale of foundations their wind farm required. It was a striking reversal. The same machine that had spent 2 years as a cautionary tale about ambition outrunning engineering was now being described as irreplaceable infrastructure for one of the largest offshore wind developments in United States history. So was Orion truly abandoned or simply delayed at the worst possible moment? The honest answer sits somewhere in between, and that's what makes this story more interesting than a simple disaster headline. For 2 years, every practical signal pointed toward abandonment. No delivery, no operation, no revenue. A broken crane sitting untouched for months before repairs even began, and an industry that had already replaced it in the field. If the failure had happened just slightly differently, if the damage had been more catastrophic, If the cost of repair had exceeded the value of starting over, Orion could very easily have joined the long list of ambitious offshore engineering projects that never recovered from their worst day. Instead, it became something rarer, a machine that came close enough to being written off that the industry genuinely wondered if it ever would sail, and then quietly proved everyone's doubts wrong. The story of Orion is really the story of what it costs to push engineering to its absolute edge. Every record-breaking crane, every vessel built to lift more than anything before it, is by definition operating in territory where failure has never been tested in the real world. The overload trial that destroyed the HLC 295000 wasn't a sign of incompetence. It was the system working exactly as it should, catching a fatal flaw before the crane ever lifted a real wind turbine foundation out at sea. Before that failure could happen, with a monopile suspended 180 meters in the air over a live construction site. The 2 years Orion spent in limbo were the price paid for finding that flaw on a test day instead of a working day. Today, Orion is once again considered one of the most capable heavy-lift vessels on the planet, quietly installing the foundations of wind farms that will power millions of homes for decades. But somewhere in Rostock, there's still footage of the day it all went wrong, of a hook giving way, a boom folding backward, and a machine that was supposed to change an entire industry crashing down before it ever got the chance. The next time you see a wind turbine standing in the middle of the ocean, remember that behind it sits a quieter story, how close the machine that built it came to never sailing again.